Hi everyone. The video for today is going to look at rotations. So when we're looking at rotation, there's two main ways that we can rotate. We can either rotate about the center or the origin, which is our middle point in a Cartesian plane, or we can rotate about a specific point. And we're going to go through both of those things in this video. Okay, so first off, we're going to look at rotating about a point. Now, the best way to think about rotation is to take it one point at a time to figure out how shapes will rotate around and how points will move. So the first thing we're going to look at is rotating 90 degrees. So remember, if we drew out a little map here, we've got at the top, we've got 0 degrees. If you rotate 90 degrees, that's that far. If you rotate again, that's another 90 degrees. So that'd be rotating 180 if it was facing the top. And if you rotated another 90 degrees, that would be 270. And then if you rotate another 90 degrees, that'd be 360. Okay, so generally you will be looking at rotating between 90 to 180 degrees. So if we're rotating 90 degrees in a clockwise direction, so moving around this way, we've got our center point given as point C. So that means everything moves around point C. Now when we rotate, the key thing to remember is everything stays the same distance away from the center of rotation. So if point B is about 2 units away here, and I might actually just change that. So I've just adjusted that so that the square is in the center. So if point B is 2 units away, so 2 squares away from C at the start, then when I rotate it, it's going to stay 2 squares away. So everything rotates in a perfect circular motion, okay? So if we look at point B first, if it's rotating 90 degrees, so we've started with this line going straight up, 90 degrees would mean point B is now going to be here. So that would be our point B. Okay. Now, if we're looking at point A starts from point B here. So at an angle here. And if we wanted to get 90 degrees, it's actually going to go across to point A will be here. So you can see that point A is actually rotated around to now be on top. Okay, so the key here is draw a line from the center point that you're working on, and then figure out what your 90 degrees would be. And lastly, check that point A is still 2 diagonal squares away from point C. So it hasn't moved further away. And lastly, point D starts down the bottom and moves 90 degrees clockwise. So you can think of it like a clock face. It's going to move up to this point here. So that would become point D. So now you can see everything's still in order. So it goes A, B, C, D, but it's just flipped onto its side. Okay. So if we were to rotate 180 degrees, that would mean it would flip to face the opposite direction. First off, you can start with the easiest one here. Point B would go all the way around to now be at the bottom of your square. And you can see point D is probably the easiest one here, would go straight around over to be over here. So that'll be point D. Once you've got point C, D, and B, point A must be over here. So it would face in the opposite direction. So when you go 180 degrees, everything just moves into the opposite direction. And you can see point C, which acts as the center here because we're rotating about point C, doesn't move because it is the center. So the center stays straight, stays the same while everything moves around it. So I'd like you to pause the video now and have a go at rotating 90 degrees anti-clockwise. So that would be going in the opposite direction, and this time with point D being your central point. So point D being your center. So have a go at that, and then I'll go through it. Okay, so point D, always easiest to get your straight up and down lines working move first. So around point D, point A moves anti-clockwise 90 degrees. That would mean it would move down to this point here. So that would be point A. And then we can look at point C would move 90 degrees from this point here, 90 degrees up to face at the top. So that becomes point C, which means point B, which is at our diagonal, has to be in between them because it's still going to be a square. And that would be DCBA. Okay, so that would be moving in the opposite direction. So you kind of treat it as a hinge point. Another good way to think about it is think about if you had a poster where you just put blue tack on one corner, it's going to swing from that corner. Okay, swing around like that rather than the whole thing turning itself. Okay, so the focus here is your central point, and always remember the distance away from the center doesn't change and the shape doesn't change with rotation. It stays the same shape. Okay, so that's rotating about a point. You'll also could be asked to rotate about the center. So our center being 0, 0. It could also be called the origin. So once again, the strategy here is to draw our line. You can draw a little dotted line here to see, to kind of give you bearings of A in relation to the center. So for us to rotate A 90 degrees, we'd need to draw a line that's going to create a 90-degree angle. And you can use a protractor here. Okay, so it's moved 90 degrees down into this direction, and we know that it's at 0.33 here, so it's not going to move further away, so it's going to stay on the point 3, negative 3. So that would be A, and you do a little dash to indicate that it's moved. So that's A dash if it was to move 90 degrees in a clockwise direction. If we're moving 90 degrees in an anti-clockwise direction, that would go into the second quadrant. So remember, this is our first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so moving 90 degrees that way, it'd still be on the 3, negative 3. So you can really use your coordinates here to help you make sure it stays the same distance away here. So that would be another A dash. We'll be moving 90 in an anti-clockwise direction. You can still stay the same amount. If we're moving 180 degrees in either direction, it's just going to go out in the opposite direction, the same distance away. So it'd be at point negative 3, negative 3, A dash. There. Okay, so drawing your line out and using your coordinates is a good strategy when you're rotating here. So let's have a look if we're rotating, lastly, about the center, square ABCD. So if we had square ABCD rotated 90 degrees about the center. So about the center just means around the center. So your center is, or we might call it the origin actually. The origin is just your middle point of your Cartesian plane, so 0, 0. So at this point, what we can do is just rotate each point individually. So we look at A, that's going to rotate 90 degrees. It's going to stay same distance apart. So that's going to be A at that point here. So that will be our point A. And if we're rotating point C 90 degrees, you can draw your little line. And then coordinate C is 2, negative 4. So it's actually going to flip a little bit here. So you can use those coordinates to help guide you as you make a rough estimate. That's about 9 degrees, and then it's going to be at negative 4, negative 2. So that will be point C. So that hand or that side is going to rotate out to here. Once you've rotated that round, it's a bit more straightforward. So you know that D is going to be diagonally opposite to A. So that will rotate 90 degrees to there. So that's going to be our point D. And B is going to be our last point. So we can fill out our square there. Okay, so it can be tricky lining up your points, but what you need to do is once you've got one side down, you can kind of work through and get your other sides there. So you draw your lines from point A to point C, and then work around figuring out your angles at one point in time. Don't try and do the whole shape at once, because that's when you might get your corners mixed around. So please email your teachers if you have any questions about that, and good luck with the activity, guys.